video, start doing some problems related to force of interest, that is the delta, what we just discussed in our previous video, right? So from this video onwards, we'll start doing some problems which is involving force of interest delta, right? The first one, if the force of interest is given as a function delta t, which is equal to 0.08 plus 0.02 divided by t plus 1, where t is larger than 0. Find an expression for the accumulation factor from time t1 to t2, where t1 is less than t2. So let's proceed with the solution. We had seen in our previous lecture about accumulation factor, which is a t1 comma t2, is defined as e to the power of integral, definite integral t1 to t2 delta of t dt. That is what is our accumulation. Now let us evaluate the definite integral separately. E to the power of, or I need not write the e then. We'll write the definite integral separately. Yeah. T1 to T2. And this delta of t is expressed in this type. So let me write that. Or let me write one more step. Delta of t dt is equal to integral t1 to t2 0.08 plus 0.02 divided by t plus 1. That is our delta of t given in the question, dt. Now we can split this integrals into two integrals. One is integral t1 to t2 0.08 times dt plus integral t1 to t2 0.02 dt divided by t plus 1. Now, first one, 0.08 is a constant, and if I integrate dt, we get t. So t, and the limiting values are t1 to t2. Then in the second one, constant term is 0.02. So it becomes integral dt by t1, t plus 1, and limiting values are t1 to t2. Now this is 0.08 times t2 minus t1. Substituting instead of t, these two limiting values, upper limit first and then subtracting with the lower limit, plus 0.02. Integrating 1 by t plus 1 dt is nothing but logarithm or natural logarithm of t plus 1, and the limiting values are t1 to t2. So that will give me 0.08 t2 to t2 minus t1 plus 0.02 times substituting this values. So we get t2 plus 1 minus natural logarithm of t1 plus 1. That is 0.08 times t2 minus t1 plus 0.0 times. This is like log a minus log b, which is log a by b. So natural logarithm of t2 plus 1 by t2 or t1 plus 1. Now we can take this to the power now. So we can rewrite this as 0.08 times t2 minus t1 plus natural logarithm of t2 plus 1 by t1 plus 1 to the power of 0.02. So this is what? This is our definite integral we started. So now our accumulation factor will be e to the power of this integral, which we evaluated already. So we can write it as 0.08 times t2 minus t1, then plus natural logarithm of t2 plus 1 by t1 plus 1.02. So that will be, let us separately write it, into e power natural of t plus 1 by 1 to the power of 0.0. This is nothing but e to the power of 0.08 t2 minus t1, okay, times. Now let me consider this whole thing as y. Let y equal to natural logarithm of t2 plus t1, t2 plus 1, t1 plus 1 to the power of 0.02, which means e to the power of y is nothing but, means converting this logarithmic expression to the exponential expression, we will have e power y will be equal to t2 plus 1 by t1 plus 1 to the power of 0.02. You can say, instead of writing implies, I will write then. So using this, we may notice this entire thing is e power y. E power y is nothing but this. So I can write it as t2 plus 1 by t1 plus 1 to the power of 0.02. That is the result. Whatever is being asked in the question, they are asking us to find an expression for the accumulation factor. Already we created the expression. This is the expression. So that's the solution for this problem. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.